Assalamualaikum everyone. Our today topic is the detailed study about the pyrrole, which is a heterocyclic compound. So first of all, you have to write the history and the discovery of the pyrrole, that it was discovered by F. Rung. Discovered it in 1837 from the coal tar, and in 1857 it was isolated from the pyrolytic bones. Now we have to study pyrrole. Pyrrole IUPAC name is azole, and it is important heterocyclic compound. Then you write its molecular formula, which is C4H5N. Then you can draw its structure as well. Now you have to write that its occurrence, that in what kind of things, in what natural products it can occur. First of all, it occurs in coal tar, as it discovered in coal tar in 1837. It is found in hemoglobin, it is found in chlorophyll, alkaloids, volatile oil, and also in the bone oil, pyrolytic bones it is present. Now hemoglobin is a red bone pigment, and it carry blood pigment, and it is a major agent to carry and transport oxygen in our body. Now we have to see, this is the structure of hemoglobin. We have a central iron atom, and we have four pyrrole ring. This is the pyrrole ring, this is this, and this four pyrrole ring combined to form a structure of hemoglobin. You have if you can remember it, then you can add this into year long. And this is the structure of chlorophyll. It also have four pyrrole ring in its structure, so therefore it is very important. Now we move on to the alkaloids. Alkaloids are the natural products, nitrogenous compounds which are whose major origin is plant, and they are physiological active. At least these compound must have one nitrogen atom. And uses क्या हैं कि they act as a they prevent plant from the predator, and they act as an anti-inflammatory agent, and they also act as analgesic agent, and they also play important role in the regulation of growth of various plants. So the major source and the origin of alkaloids is plant. Okay, and these alkaloids are also used in the formation of various medicines. Okay, now we move on to the volatile oil. Volatile oil also contain pyrrole. These volatile oils evaporate when they exposed to the air at the normal room temperature. It also called as essential oils, and it also present in various plants. Now we move on to the structure of pyrrole. That what is the structure of pyrrole? We see this is the structure of pyrrole. In pyrrole, the carbon has sp2 hybridization. Carbon hydrogen also has sp2s hybridization, and nitrogen and hydrogen also has sp2 and s sigma bond hybridization. Now the pyrrole has four carbon atoms and one nitrogen as a heteroatom in itself. All the four carbon atom and nitrogen atom is sp2 hybridized. Now and these carbon atom and nitrogen attach with the 1s hydrogen atom and overlap with itself. All the pi bonds, sigma bonds lie in a plane. Now we have discussed sigma bond distribution and the total sigma bonds in it. Now we move on to the unhybrid orbital which are present in pyrrole. Each carbon on the ring of pyrrole has one hybrid orbital, and the carbon has one electron while the nitrogen has two electrons. So in this way we have four carbon atoms, so four electrons from the carbon and two electrons from the nitrogen combined to give unhybrid six pi electrons. So therefore, due to presence of six electrons, an unhybrid orbital lie perpendicular to the pi bond, and these six unhybrid pi bonds form a ring-like structure in the nitrogen atom. Now, short-handed representation of pyrrole is that the pyrrole can be represented by making a circle inside the pentagon, and it represents pi molecular orbital. Okay, now this can be representation of the pyrrole. Now we move on. we discussed the resonance structures of the pyrrole. First of all, that the resonance structure of pyrrole came due to the lone pair present on the nitrogen atom. These lone pair resonate and form different structure. First of all, this lone pair is present on the nitrogen atom. Now this lone pair is displaced to this side, okay, and this lone pair came here, and this bond shifted to this side, and this bond also this bond shifted to that side. Okay, first of all I make arrow for you. This bond transfer here, this bond transfer to there, and this bond transfer to there. Okay, now this bond move here and here. Now this pi bond move uh, at that part, okay, in this way, and now this bond move to there, and this bond move to there. Okay, so if this bond is there, then this structure is formed. Okay, this bond transfer to there and there. Okay, now if this bond transfer to, this is the lone pair. Now if this lone pair transfer to there, then this structure is formed, that this bond transfer to there and this bond transfer to there. Now if from here, if lone pair transfer to there, then this remains same, and there is the bond formation. So in this way 5 bond फॉर्म. सो अगर मैं आपको ट्रिक बताऊं इस रेजोनेंस स्ट्रक्चर को बनाने की, तो अपने पायरोल में जितने भी कार्बन एटम है सबके आगे लोन पेयर लगा देना है. फॉर एग्जांपल पहले आपने इस साइड पे लोन पेयर लगाना है, अगली स्ट्रक्चर में आपने इधर लगाना है, फिर इधर लगाना है, फिर इधर लगाना है. अब जिस तरफ लोन पेयर होगा ना, उसकी 2 साइडों पे बॉन्ड नहीं आएगा, इधर और इधर आएगा. ठीक है, अब ये देखें यहाँ पर बॉन्ड इधर है, इसकी ये वाली साइड और ये वाली साइड पे बॉन्ड नहीं आया, बाकी अल्टरनेट साइड पे आ गया. अब बॉन्ड इस तरफ है तो इसकी इस साइड पे और इस साइड पे बॉन्ड नहीं आया, बाकी जगह आ गया. अब बॉन्ड इस तरफ पे है तो यहाँ और यहाँ पर नहीं आया और बाकी तरफ आ गया. तो ये रेजोनेंस बनाने का एक शॉर्ट ट्रिक बता दिया मैंने आपको. अब हम फिजिकल प्रॉपर्टीज़ के बारे में पढ़ेंगे. ये कलरलेस लिक्विड है, बॉइलिंग पॉइंट इसका 131 है और -23 इसका मेल्टिंग पॉइंट है. स्लाइटली सोल्युबल है वाटर में, ज़्यादातर ऑर्गेनिक सॉल्वेंट में सोल्युबल होता है. स्टोरेज हम इसका करते हैं डार्क एरिया में और अम्बर कलर वाटर में. स्मेल इसकी क्लोरोफॉर्म की तरह है और इसको डार्क एरिया में स्टोर किया जाए, और इट ऑक्सीडाइज व्हेन एक्सपोज टू द एयर, देयरफॉर इट कंटेन डार्क ब्राउन कलर. Chemical property, it is more aromatic than the benzene because of the presence of pi electronic bond. So it show electrophilic substitution reaction, for example halogenation, nitrogenation, nitration and sulfonation. Okay, it also undergo diazotation, elemental Tenman reaction, and while benzene cannot. And how it undergo electrophilic substitution reaction, now we study it. So first of all you have to write the discovery of pyrrole, which is that it is discovered by F. Rung in 1834, and in 1857 it was discovered in the pyrrolated bonds. Then you have to write its molecular formula and explain that it is very important heterozygous compound. Then you have to write its occurrence, that it occur in hemoglobin, chlorophyll, volatile alkaloids, coal tar, and bones oil also. So if you have remember the hemoglobin or chlorophyll structure, then also write it. It's plus point here. And then you have to write about alkaloids, that they are occur in plants and they are physiologically active. They contain at least 1 nitrogen atom, so they are nitrogenous compound, and they prevent plants from pathogens. They are energetic and they are anti-inflammatory. They regulate their growth. And then you write about the volatile oil, that they expose to air, they volatile in air at room temperature, and they also called as volatile essential oils, and they are very important and their origin is in plant. Okay, then you have to write about the structure of pyrrole. You have to explain that all the carbon atom and nitrogen atom has sp2 hybridization. Then the unhybrid orbitals form pi bond, and then you have to write shorthand representation of the pyrrole. Then you move on to the its resonance structures, and then you write its physical properties, and then you move on to its reactions. for example, chemical properties of the pyrrole, that it is very aromatic and what kind of reaction it shows. Then you move on to the electrophilic substitution reactions. Now we have to see that electrophilic substitution attack at third position or second position. And why we call that always electrophilic substitution occur at two positions? So there is the explanation, because when their electrophilic substitution occur at third position, two in resonance intermediate products are formed, so it is less stable. When the attack occur at two position, three resonance structures are formed, so therefore it is more stable. Now how these intermediate products form? For example, this is the electrophilic group. This attack at the third position. So at third position, E and H is formed, and this bond break up. This remains same bond. Then this nitrogen lone pair shifted to there. As you see this, and there is positive charge at this side because the bond go away. So as the nitrogen donates its lone pair, so therefore positive charge come of nitrogen atom, and this lone pair form a bond there, as you can see. And this hydrogen atom remove only electrophile group attached there. So in this way two intermediate products form when attack is occur at the three position. When attack occur at two position, now the electrophile attack, the intermediate products are three which are more stable. First of all, this electrophile attack at the two position, this bond break, you can see there. Now what you have done, because this bond break up, so therefore the positive charge occur at the three position here. So to remove the positive charge, this bond is too much near, so this bond is transferred to this side, as you can see there. So as it's transferred there, so at this side there is deficiency, so nitrogen donates its lone pair toward this side because positive charge is present there. So here bond is formed, and this positive charge transfer on the nitrogen atom. So in this way it has three stable structures, so it is more stable. Now the important reactions of pyrrole, that it is acidic character and basic character of pyrrole is shown. First of all, it is a weak acid as acetylene. It reacts with metallic potassium in presence of an heptane solvent to form potassium pyrrolide. Okay. Now we move on to show the basic character of pyrrole, that it reacts with H inactive. It is an inactive base. It reacts with a strong base which is KOH. K move on to the hydrogen, and this hydrogen released to form H2O. Okay, nitrogen has negative atom and potassium has positive, so potassium pyrrolide is formed. Okay. Now we move on to the oxidation, reduction and the halogenation and other reactions of the pyrrole. First of all, it undergo oxidation in the presence of acetic acid and nascent hydrogen to form melinite. It is the amide of acetic acid. As you see the structure here, double bonded oxygen attached there. Now we move on to the reduction of pyrrole. Now pyrrole undergo reduction in the presence of acetic acid and zinc oxide. First of all, 2,5-dihydropyrrole is formed. This is the structure of 2,5-dihydropyrrole. Then in the presence of red phosphorus and hydrogen iodide, it converts into the pyrrolidine. Okay, it also called as tetrahydropyrrole. Okay. This is the reduction of pyrrole. Then we see the reactivity, that the pyrrole is more reactive than the benzene. Now the order of aromaticity, that the most aromatic among the heterocyclic compound is thiophene, then pyrrole, and then we have furan as aromatic compound. Next we move on and we discuss the nitration, sulfonation and the halogenation. First of all, nitration occur in presence of acetic anhydride, and this attack occur at which position? Which you suggest? at two position, because I call to you, I tell to you that at two position three resonance structures are formed, so it is more stable. So therefore when the pyrrole undergo halogenation, sulfonation, nitration, it always attack at the two position. Okay, so two nitropyrrole is formed. Now in sulfonation, in presence of pyridine at 30 degrees centigrade, H2SO4 attack on it, and this sulfate group attack at the two position, and two pyrrole sulfonic acid is formed. Now halogenation occur in presence of thiol at 0 degrees centigrade. Okay, and the reaction is that pyrrole react with three bromide ions, and the 2 3 4 5 tetrabromopyrrole is formed. Now this is the detailed study about the pyrrole and the synthesis of pyrrole. I have discussed you in the first lecture. You can see this video. The pyridine we study in the lecture. Stay tuned, and please like, subscribe this video. I hope that you will like it. Allah Hafiz.